Okay, then behavior of polynomial functions. So, as we know, polynomial functions, they twist up and down based on many factors, but we're not gonna take a look at those. We're gonna ignore what's happening in the middle. But what we're gonna take a look at here is how is its beginning and how is its end, because sooner or later any polynomial function, as it goes towards negative infinite or positive infinite, eventually it will become forever increasing or decreasing. So therefore it's very easy to determine the end behavior. So we're gonna take a look at first the leading term. That's the key term that will tell us everything we need to know about end behavior. We're gonna have 4 scenarios. We're gonna see the scenario when the n on the exponent is even. Then we're gonna check when n on the exponent is odd. And each of these scenarios will have 2 subsections where the coefficient is bigger than 0, smaller than 0, and here's the same. Bigger than 0, smaller than 0. And I'm gonna draw up some examples here so we can see what are we talking about. So, the first one. fx equals 2x to the 6th minus 50x cubed plus 4x. Okay, just like we mentioned here, we're not really gonna worry about what is happening back here. Our focus is right here, our leading term. Our exponent is even, so this means that the beginning and the end of the function will face the same way, either up or down. We have an even, there you go, and our an is bigger than 0. An is bigger than 0. 2 is bigger than 0. So therefore, we know that the function in the middle will move up and down. It'll do whatever it'll do. But since it's even, it'll face the same way, and bigger than 0, we know that it'll face upwards. So therefore, the end will be up. The end will be up. And these two, it can do whatever he wants in the middle, but the beginning and the end will always be like this. Okay, let's take a look at if it's our coefficient is negative. So I'm gonna write a function for this. G of x, let's say negative 2 x minus 5 x plus 1 on the cube. Okay, this one, it's a little bit harder to see, but we need to find our leading coefficient, leading term. So we're gonna take the 2, we're gonna take the x, we're gonna take the x from here. We're gonna, same thing as foiling this out, just multiply it out. I'm just gonna multiply out only the very first term. So 2 negative 2 times x cubed. And this will give us a negative 2x to the 4th. And this will be the leading term of our polynomial function. Now, our exponent, we can see it's even. That means beginning and the end will either face up or down, both of them in the same direction. But as we can see, we have a negative 2 in front of the x, so this means it'll face down. So our function will do whatever it wants to do in the middle. We don't pay attention to that right now, but what we know for sure, that the end will go down and the beginning will also go downward. So these two parts, we know for sure that this is how they behave. Now let's take a look at some examples when the exponent is odd. fx equals x to the fifth plus 11x to the third minus 3. Okay, what we're gonna see, notice here, our leading term is right here. Our exponent is 5, which is odd, and this will mean that the beginning and the end will not face the same direction anymore. One will be up, one will be down. Either this one will up, one down, or one down and the other one up. So when our coefficient is bigger than 0, here we have 1, which is bigger than 0. Therefore, we're gonna have a function that looks in the middle. Again, it can do whatever it wants to do, but the beginning and the end, we know for sure that it will behave like this. This is for sure. Now, let's see if our leading coefficient will be smaller than 0. Let's see, gx equals negative 4x to the 7 plus 6x squared minus 5x plus 169. Now, just like before, all this stuff can be as long as it wants. We don't pay attention to it. We just care about the end behavior right now. That we need the leading term for it. Our exponent is odd, and our an, the leading coefficient, is negative. Negative 4 is smaller than 0. Again, same situation like here. The end and the beginning will not face in the same direction, but since this is negative, it will be like this. In the middle, we don't know, it'll do whatever it wants, but the beginning will be upwards, and then the end will be downwards. And these ones we know for sure. Alright, and these are the 4 scenarios based on which we can always determine the end behavior of a polynomial function.